All right, geometry, welcome back. Today we are jumping into a new unit. You should have looked at it a little bit already with our central circle, the Desmos, and that captain's wheel Desmos, where you're looking at central angles. But we're going to look at angles of circles today. We're going to talk about another type of angle called an inscribed angle that we're mainly going to look at in this video. But we're going to start off this warm-up. To calculate the measure of x in the circle C shown below, Emma set up the following equation: 3x plus 12 plus 8x minus 8 equals 30 or 360. Is Emma on her way to the correct answer? If so, solve for x. If not, explain. So Emma, in this question, saw that this arc right here was 3x plus 12. And then this arc right here was 8x minus 8. Now we can see that this line that passes through C is a diameter because it passes through the center of our circle. So diameter is a line that passes from one side of our circle to the other side of the circle that passes through the center. So if it passes through the center of our circle, a diameter has to cut your circle in half. It has to dissect or bisect your circle into two equal parts, which means if we cut the entire circle into two equal parts, we know that each of those parts have to be 180 degrees. So rather than having 3x plus 12 and 8x minus 8 equal 360, Emma should actually have this equal 180 because we know our purple segment plus our red segment together is going to equal half of our circle, which is, once again, 180 degrees. So she was close. She almost had it set up right, but she had it set up to 360 instead of 180 instead. All right. So from there, you could just add your, it's just algebra. You add your x's together, add your constants together, subtract your constants, inverse your coefficients, and then you're good to go. All right. So we have three examples on this board. So I have two inscribed angles, and I have one angle that is not an inscribed angle. So looking at these, what are some things that you notice about these angles? What are some things that you notice that are similar about your inscribed angles that's not true about your non-inscribed angles? One big thing you probably see is that the vertex of each of these angles, each of our inscribed angles, is on the edge or the outside of our circle. So our vertex of our inscribed angles are on the edge of your circle. Well, if I look at the vertex of my non-inscribed angle, it is on the inside of my circle. It's not on the edge of my circle. So in order to be an inscribed angle, we have to have the vertex on the edge of our circle. So based on that slide, explain what you think an inscribed angle is. So an inscribed angle has its vertex on the edge of the circle. So that's what we saw, circle. That's what we just saw in that last thing. So now let's look at these three inscribed angles we have here. So what do you notice about the inscribed angle compared to its intercepted arc? So I have 80 degrees is my inscribed angle, and then this green arc right here that falls within the edges of my inscribed angle, that is called the intercepted arc. So my intercepted arc in this case is 160. I have 50 degrees for my inscribed angle. My intercepted arc right here is 100. I have 30 degrees for my inscribed angle. My intercepted arc is 60. So one pattern you're probably noticing about these is that the intercepted arc is equal to 2 times our inscribed angle. It's double. So all of these are double our inscribed angle. So if we see 160, 160 is double of 80. 50, if we double it, gives us 100. 30, if we double it, gives us 60. So that inscribed angle times 2 will always be equal to your intercepted arc. And we can use this to solve for a lot of things. For example, if I have these problems and I want to solve for my x's, I can easily use my inscribed angles to solve for those. If I have an intercepted arc of 90, well, I just know that's double my x, my inscribed angle. So I can take 90 divided by 2, and that's going to give me 45 degrees. So that would be my inscribed angle. If I have 37 as my inscribed angle, I know my intercepted arc is just going to be double that. So I can take 37, multiply it by 2, and that's going to give me 72 degrees. 74 degrees. I lied. I'm sorry. 74 degrees. Mr. Jarvis can do math. That's going to be that intercepted arc. All right, this one's a little bit harder because if I look, this arc right here is not my intercepted arc. It's a small piece of my circle. But if I look, I see that this line right here is the diameter. So I know that this total arc up here has to be 180 degrees. Well, if I have an inscribed angle of 50 degrees, then my intercepted arc, this portion of my 180, has to be 100 degrees. So how much is left of my inscribed angle? How much is left of my 180? Well, if I have 180 minus 100, this just leaves me with 80 degrees left is my x. So those are how we can use inscribed angles to solve for it. You'll have a little bit of extra practice over inscribed angles after this video, practicing solving for things like this. Let's look at another thing. Okay, what is the value of x? So I have this inscribed angle right here. I'm trying to solve for what is the value. If I look at the intercepted arc of that inscribed angle, I get this green arc. The only other information is I have this red inscribed angle. But if I look at the intercepted arc of my red inscribed angle, it's the exact same arc as my other inscribed angle. So using that information, if I were to double this, my intercepted arc would just have to be 124. Well, if I cut 124 in half, that's just going to give me 62 again. So anytime you have two inscribed angles that have the same intercepted arc, those angles have to be the same because we're, once again, doubling for the intercepted arc and then dividing in half for the inscribed angle. So it's always going to be the same as long as they inscribe the same, or as long as they intercept that same arc. It will always be the same. All right, what about this one over here? I have an intercepted arc of 200. I have an inscribed angle of 28x minus 12. So I know that if I cut my intercepted arc in half, this cut in half gives me 100. So I know my inscribed angle is 100 degrees. Well, how can I solve for x? Well, if I know that it's also 28 minus x, or 28x minus 12, I know that has to equal 100 because it's half of my intercepted arc. I can just easily solve this for x using a little bit of algebra. Add 12, and we get 28x equals 112. Divide by 28, divide by 28, and that is actually one I don't know off the top of my head. 112 divided by 28, and my calculator is way over here. It's going to be like 4 something. 112 divided by 28 gives me 4. Yep, it was 4. Should have just gone with my gut. There we go. All right, and that would be our x. So once again, even if it has some algebra like this and it has an expression, as long as you know what that angle is or what the intercept is, we can easily set it up to solve for our missing angle. Last question. All right, an inscribed angle A. And so let's restart. In the circle A, angle CBD is an inscribed angle. What is the measure of CDA? All right, so I have this inscribed angle, CDA. That should be CBA. Oh, CBD. Sorry, I'm not reading anything right. Okay, so I have CBD is my inscribed angle of 36 degrees. I'm looking for C. It should be this one. I'm sorry, this is wrong. This should be CAD. I had my letters wrong. I'm sorry. We're looking for a measure of angle CAD. So we're looking for this angle right here. Well, how can I solve for this? I know that if I were to take 36 and I were to double it, I would get 72 degrees as my intercepted arc. Well, I know central angles, like what we just saw. Central angles and inscribed angles, or central angles and intercepted arcs have the same degree. So that means my angle here would also have to be 72. And so essentially, if you have a central angle and an inscribed angle that have the same intercepted arc, the inscribed angle is always going to be half of your central angle, or your central angle is always going to be double, because once again, we know central angles have the same angle measure as their intercepted arc. Inscribed angle measures have the half of their intercepted arc. So we have essentially two types of angles that we want you to remember. We want to talk about inscribed angles and central angles. You have a little bit more practice with this today. Let me know if you have any questions, and we'll stop our video right there.